what's called a determinant of a matrix. I want to make a quick review on it. I will skip some slides. We will talk about them later. But the main thing about evaluating certain determinant, you will have to know a little about it. I want to refresh your memory about this part, which is very, very simple.
Is getting the determinant for a 2 by 2 different from getting
Yes, or 3 by 3 or so. So determinant and their properties. Determinants in linear algebra is just in linear algebra, just a value associated with a square matrix, can be computed from the entries of a matrix, which is very, very simple. So if you remember, if I have a 2 by 2 matrix, let's say for any values, if I have 5, 2, 6, and the negative 1, and this is the matrix A, if you want to get the determinant of A, it's very, very simple. All I have to do is to get the multiplication of the principal row. So it's going to be 5 times negative 1, then minus for the other side. So it's going to be minus 6 times 2. So it's going to be negative 5 minus 12 for this problem. So it's going to be negative 17. And that's for evaluating a value of a determinant. It's exactly like for us multiplying 5 times 2 minus 4, which is going to be 6. Okay, if I have 3 by 3, I want to introduce to you the Saras rule and the Gauss method. The Gauss method states simply, it's really very simple, which means that I will have to break this 3 by 3 matrix using the cofactor method. How to do it? Simply, you will have to know a little about the sign rule. The sign rule of determinants states that I will start by positive, negative, positive, then I will go zigzag, negative, positive, negative, then positive, negative, positive. Or in general, it's minus 1 to the power of I plus j. So this is the sign rule. It's minus 1 to the power of I plus j. What's I plus j? The entries or the number of row and column for each entry in a matrix. So if I have this determinant, which is 10, corresponds to a matrix with term negative 3 and 5. The second column, which is 7, 4, and 6. The last one is 0, 6, and 5. If I want to use the first row to get the value of this determinant, what I have to do, I will start with 10. Then I will eliminate the row and the corresponding column. So I will end up having 4, 6, 6, and 5. Then I will write the sign, which is negative. I will go for the number 7, eliminating row and column, and the remaining set will be simply negative 3, 6, 5, and 5. And for the last value in the first row, which is 0, I will go plus a 0, eliminating the first row and the last column, and I will have the value of negative 3, 4, 5, and 6, and this how I will get the value of this determinant. Once more, I can get the result directly. Actually, there is another method which I myself use a lot, which is Saras rule. طيب تعالوا بقى بص على Saras rule دي عايز اقولها لك مستر فراس. I will get the multiplication of the elements of the principal diagonal, which are 10 times 4 times 5. Then remark this principal diagonal actually divide the square determinant into an upper triangle and lower triangle. صح? Okay, multiply the base of the upper triangle by the lower vertex, by the vertex of the lower triangle. Once more, the upper base times the lower vertex. Let's do it. 7 times, so plus 7 times 6 times the lower vertex, which is 5. Then I will do it similarly like. but with the lower base,
In the
okay,
upper-
in the upper vertex, which is gonna be simply -3 times 5 times 0. In a similar manner, I will do it, but on the secondary row. So I will go for the secondary. Here we go. For the second direction. So it's gonna be minus and open. 0 times 4 times 5. Exactly the same. 0 times 4 times 5. But this time I'm using the secondary diagonal. Also, I will get the multiplication of 6 times 6 times 10. So it's going to be plus 6 times 6 times 10. Then plus 7 times -3 times 5. 7 times -3 times 5. And I will get the result of this matrix. I'm sorry, of this determinant. So once more, 10 times 4 times 5. Then plus 7 times 6 times 5, then plus -3 times 6 times 0, minus 0 times 4 times 5, minus 6 times 6 times 10, minus 7 times -3 times 5, as you can see. Now I can get the result of this matrix. Here's the cofactor method. Taking t, eliminating the first row and first column, you will end up having a smaller determinant. I will evaluate it 4 times 5 minus 6 times 6, which is going to be simple. Simply like, take the sign rule, which is -7, eliminating row and column, -3 times 5, minus 6 times 5, like this one. And finally, 0, eliminating the row and column, times the lower minor, which is -3, 4, 5, and 6. But I'm not going to evaluate it since this value is equal to 0. This way, I can get the value of the determinant 3 by 3. Okay. Remark, the transpose of a matrix doesn't change the value of a determinant. So if you have a matrix and you know its determinant, if you get the transpose of that matrix, it will be the same. Okay, so there is no change. So if I change the rows into columns, so here's the transpose, the value of the determinant will be the same. There will be no change. Okay, also these are the 3 main operations that we use with matrices, which is multiplying a row by a number, multiplying a row by a number and adding it on another row, or switching rows. Switching rows in a determinant will change its sign. So if I have this determinant, for example, and let's say the value will be, the value will be 1 for this determinant. If I just replace the second row instead of the first row and vice versa, so if I make it -3, 4, and 6, then 10, 7, and 0, this is 5, 6, and 5. The result of this determinant will be just a negative sign of 1.
Does this work if we switch out any rows, or does it have to
No, yes, exactly right.
Okay.
Any rows. If I made another switch, then the sign will be a positive. And it goes for rows and columns. Okay, if I multiplied this matrix, this determinant by a number, it will be multiplied in 1 row. And this is the difference between matrices and determinants. In matrices, once you multiply by scalar, all the elements will be multiplied by scalar. But in determinants, once you multiply, it will be multiplied by just only 1 row or 1 column. And we will go through this later, inshallah, after the next week. Determinants of elementary matrices, as I told you, by the idea, if you multiply a row by a number and added it on another row, it will make no change in the value of a determinant. And this is really very interesting. Here is the states about the elementary matrices. Okay. I will skip this part, which talks about how to get an inverse of a matrix using the determinants by getting the cofactors. Then just rewrite them, or getting the transpose, which is called the adjoint matrix, dividing it by the inverse by the determinant, you will get the inverse of a matrix. I will go through it next week, inshallah. This is for how to get the inverse. I'll skip this part. You already know about Gauss-Jordan, which is more applicable. This is the cofactor as I told you about. I've skipped this part because I want to talk with you about the midterm exam itself. For this part, let's go through some problems and see how it works. Here, for example, for this problem, he's giving you, okay, he's giving you the set بيقول which of the following sets is not a basis for the column space of 1, 0, 3, 0, 1, negative 2, which is basis, 1, 1, and 1. I will try to seek the basis. What do you know about the basis? What do you know about basis? It should be linearly independent. So you are searching for a linearly independent set of vectors that can generate this vector space. So how to do this? It's really very simple. All I have to do is to get the solution of the system, Ax equal to 0, for all of them, or for each one of them. If you reach it, okay, the state that you have, you can't get any one of these vectors from each other, then you will have the set that you are talking about. The basis should be generating a generating set of vectors, and also should be linearly independent. Okay? So if you like to check the first set of vectors, so if we want to do it quickly, but I have a lot of problems, which is more than this problem, or more important than the idea of this problem. انت معايا يا فراس؟ فاهم انا بعمل ايه؟ عشان اقدر اعرف البيزس لازم تكون الفيكتورز اللي انت شايفها قدامك دي linearly independent. يعني ايه linearly independent؟ يعني there is just only K1 and K2 that will get these values equal to كام؟ to 0. فاهمني؟ ده اللي انا بقول عليه ايه؟ البيزس عشان يقول linearly independent. يبقى انا لو جيت على الفيرست set of vectors اهي which is 1, 0 and 3, بعدين 0, 1 and negative 2, بعدين 1, 1 and 1. Try to reduce this system. Reduce the system by getting echelon 4. اشتغل على echelon 4. يبقى إذا على طول عشان أقدر أجيب ده أكنك بص أكنك بتجيب C1 V1 plus C2 V2 plus C3 V3 which equal to كام؟ to 0. لو أنت لقيت C1 C2 C3 not equal to بيساوي zeros على طول يبقى ديت البيزس بتاعتك. طيب if ان عندك infinite number of solutions هختار من الست اللي موجود قدامي الفيكتورز اللي بيظهر بيبقوا pivot for in the echelon form. So let's start. Multiplying the first row by negative 3 and added on the last row. يبقى ده 1, 0 and 1. Negative 3 plus 3 the result will be negative 3 times 0 plus negative 2, so it will be negative 3 plus 1, so it will be. The second row is 0, 1, and 1. As you can see, these two rows are images from each other. If I multiply this by 2 and add it, I will have the following form. بص كده. Which is 0, 1, and 1. 1, 0, and 1. Which means I will take the pivot of the first row. اوكي؟ يبقى انا هاخد الفيرست فيكتور، ده الفيرست فيكتور اللي يعتبر linearly independent. وبعدين عندي البيفوت بتاع السكند رو، يبقى اخد السكند فيكتور. ترجع للماتريكس بتاعك. مين الفيرست فيكتور؟ 1 0 3. مين السكند فيكتور؟ 0 1 ومين؟ يبقى اذا this is the correct choice. ده الكوريكت تشويس. معايا؟ الاولاني اصلا انت رفضته دلوقتي. لأنه واضح إن الثيرد فيكتور can be a linear combination from the first two factors. وبالتالي أنت لما جيت تريفورم ده لقيت لك يساوي كام؟ يساوي 0. معايا يا مان؟ أوكي. يبقى إذا this is the first set as I told you about. يبقى إذا ديت الست بتاعتي أنا عرفت أطلعها. طبعًا لو أنت جيت تبص للفيكتورز دي وحاولت تشوفهم هتلاقي الباقيين كلهم linearly dependent on each other. يعني الفيكتور ده أقدر أجيبه من ده والفيكتور ده أقدر أجيبه من اللي تحت. طيب طبعا انت عندك البايثون، انا قلت لكم تحاولوا تتصلوا بالدكتور محمد واكدت على رامي بس hopefully انه يعمل كده ايه. هنا بيقول انت عندك consider a 2 by 2 matrix such that الديترمنت بتاعها بيساوي كام؟ 4. And the trace, do you remember what's the trace of a matrix? What's the trace of a matrix? Trace of a matrix is the sum of the principal diagonal elements of that matrix. يبقى الsum بتاع المين diagonal which is called a trace of a matrix. So simply لو انا جيت بيقول كمل بقى بيقول what's the determinant of the matrix A plus I where I represent the 2 by 2 identity matrix. Okay, what to do? Any ideas? What's the A matrix? He's giving me nothing about that matrix. صح؟ بس قايل انها 2 by 2.
Okay.
So simply the A matrix can be put as A, B, C, and what? D. And D. I have the following, that the determinant of A equal to 4, yes?
Yes.
And the trace of A equal to
1.
What's the trace of this matrix? A plus D should equal to 1, yes?
Okay.
And the determinant of A, which equal to 4, is supposed to equal to A times D, am I right?
Yes.
Minus B times C, yes?
Yes.
There is, and he wants to know what the determinant of A matrix, which is A, B, C, D, plus the unit matrix, which is 1, 0, 0, 1, am I right?
Mm-hmm.
Which is gonna develop A plus 1, this is B, C, and you will have D plus 1, am I right?
Okay.
Get the determinant of this matrix. So the determinant of A plus I, which is required, is simply A plus 1 times D plus 1 minus B times C.
Okay.
Which is gonna result, if you try to expand these two brackets, it's gonna be A times D, and then you will have A, then 1 times D plus 1 times 1. Are we right?
Mm-hmm.
Okay. So it's an A times D, then you will have A, then D, then I'm sorry, 1 times D, then 1 plus 1. Okay, let's take a look of this 4. Of course, this is minus BC. Remark, I have AD, yes, minus BC, yes?
Mm-hmm.
So I have AD minus BC. And also I have A plus D, yes? And this is minus 1. I'm sorry, this is plus 1. So it will equal to A times D minus B times C, which is equal to 4, yes? And the trace is A plus D, which is positive 1. And then you will have, which is, just a second, I'm sorry, this is minus 1. Okay, so you will have this minus 1 and this is plus 1. So they will cancel each other and the result will be 4. يبقى إذا على طول هبدأ أختار the correct choice, which is 4. So simply, if you want to solve this problem, use just simply the determinant of A plus I and use the various substitutions that will appear in your problem. This is also this is the second question about Python in this exam. Okay, this one is very simple. Okay, let's state what he wants. Okay, read. Consider that B is these two matrices, which is a
basis for
what we mean about basis? Two vectors that if you multiply them in the right coordinates, you will get any vector that you want.
Okay.
Okay, continue. For a vector spaces, find if possible the matrix whose coordinates vector is the basis for in the basis B is -1 and 2, which is a really very simple question. Do you know the answer? The answer is really very simple. Very simple. All I have to do is to remember that any vector in a vector space, just a linear combination of the bases of this vector space. So simply, all I have to do is to multiply -1 by the first vector, which is 0, 2, -1, and 0, and then added on it the second coordinate, which is 2, times the vector, which is 1, 0, 0, and 1. Okay, I'm sorry, it's all in a matrix notations, of course. So the result of this matrix that you're searching for is -0 plus a 2, -2 plus 0, I believe. Then I will have 1, yes?
Yes.
And 2, and the choice will be, okay, 2, 1, 2, -2, 1, and 2. I believe this is the right choice, yes? It's not difficult, yeah? Okay, perfect. But it depends on your understanding between the coordinates and the bases, yes? Okay. طبعا مكتوب طبعا the linear combination, any component from a vector space equal the coordinates and vector space. Here he's giving you, يقول لك in a general solution of a system of linear equation Ax equal B. x1, x2, x3 equal to 1, 0, 1 plus an A times 1, 3 minus 3. خدت بالك يا فراس ان ده السولوشن سيت بتاع اكس دي زائد النار A of A. واخد بالك؟ طيب يقول لك بقى which proposition can be true؟ أنا proposition تقول لي be true، أعمل إيه؟ وبيقول إيه؟ بيقول خلي بالك إن أنا عندي general system of equation Ax equal B. As you in general solution, F a general solution. So this is actually the general solution. صح؟ solution set كان بيساوي إيه؟ solution set كان بيساوي ايه؟ بيساوي اكس بي صح؟ زائد السبان بتاع او اللي انا بسميه النل بتاع الايه، مش كده برضو؟ يعني اذا الجنرال سوليوشن ده انا اقدر اكتبه، مش كده برضو؟ اقدر اكتبه ازاي؟ هيبقى ده عباره عن، خلي بالك الشكل اللي قدامي ده انا اقدر احطه ازاي؟ اقدر اجيب الاكس 1 والاكس 2 relative للفاليوز دي واشوف which one of these values will give me that form. تعالوا start by the first one, which is simply it's gonna be 3x1 معايا في راس minus x2 equal 3. The second equation, which is x2 plus x3 equal to 1. ده اللي انت بتاخده بعد ما تحل الاشلون فورم وتيجي على الفاينل ستيتس وتحكهم equations, which means and now you have, which implies that you have 3x1 which equal to 3 plus mean x2. For the second one it's gonna be x2 which equal to 1 and then minus mean x3. صح يا مان؟ Okay. The next step بعد ما انا عملت ده I will try to divide on 3. So x1 will equal to positive 1 plus 1 over 3 times x2 and x2 will be 1, okay, minus the value of x3 صح؟ برضو؟ اوكي طيب ومعنى ذلك ان انا عندي x3 it's exactly the same. So x1 equal to 1 plus 1/3 of x2 x2 1 minus x3. Okay, perfect. So here's that's x2 which already exists on our system. دي value بتاعت x2. يبقى انا جبت x1 as 1/3 of x2. This is x2 already exists in our system, and the last one is 1 minus x3. Remark that x2 doesn't contain any number here, yes? So I can write the xd for this set, which is gonna be 1, 0, and 1 for the coordinates x1, x2, and x3. and this is gonna be plus 1, instead of x1 I will have 1/3 of x2. يعني بص في راسي اللي انا عايز اقوله ان انا عندي دلوقتي x1 x2 x مين؟ دي الكوردينت صح؟
اوكي.
هشيل x1 واحط مكانها كام؟ 1 plus 1/3 of مين؟ of x2 وبعدين x2 as it is بعدين x3
1 minus
معايا انا جبت كده بعدين x2 ده x1 just a second بعدين انا عندي x2 اللي هي بتساوي x2 و x3 I'm sorry for this x3 بتساوي 1 minus مين؟
x2
1 minus x2 لازم اجيب 2 variables بدلاله التاني يبقى عندي x2 بتساوي x2 اهي بعدين x3 I will insert 1 minus x2 which simply can be put on this rule. بص 1, I don't have numbers here, so it's 0. The last one is positive 1. Then I will have plus, which is going to develop 1/3 of x2. بعدين أنا عندي x2. بعدين عندي minus x2 صح؟ يعني أقدر أخليهم 1, 0 and 1 plus some value and I will have 1/3, 1 and the negative 1. Am I right? صح؟ طيب x2 I don't like it. My x2 belongs to R. Yes? I will consider it is 3c. أنا أعتبرها 3c. لو حطيتها 3c ده يدي لك 1, 0, 1 plus 3 times 1/3 which is 1. 3 times 1 which is 3. 3 times minus 1 which is negative 3. And this 4, it's really very close to that one. So actually, this is the correct answer. If you run to this answer, it's nonsense. What do you have to do with the 3 minus 3 times a? You don't have something like this. Doesn't mean anything. The system is x1 plus x2 equal 2, x2 plus x3 equal 1. If you try to move it to the other side, so x1 is going to equal to 2 minus x3, x2 1 minus x3. So the values of x3 should start with 2, 1 and something, and you don't have that here. So it doesn't make any sense also. The last one is a times 1, 0, 1, which is nonsense. This is the part of the solution. Do you read me? اوكي فهمت انا عملتها ازاي؟ انا فكيت وتشكيت بس النقطه هنا ان انا I will have to get 2 of these coordinates as a function in the third one. اوكي لذلك انا رحت مستخدم هنا x3 as a function in x2. I'm sorry. يبقى from this equation اوكي وده اللي احنا عملناه تحت ان انا اجيب x3 تبقى 1 minus مين؟ x2. This how you have x1 as a function in x2 and the x3 is also a function in x2 بالتالي اقدر Okay, get the general solution of each of them and compare them. Okay, for this problem, which of the following option corresponding to the null space of this matrix? How to get the null space of the matrix? Once more, how to get the null space of the matrix? 1, 3, 2, 1, negative 2 and 1. Then I will have 5, 0 and 1. Yes? Try to solve the system, ax equal to what? To 0. And this how you will be able to get the null solution.
Okay.
So all I have to do is to try to solve this homogeneous system.
Okay.
Start solving this homogeneous system. I will continue this problem with you. and I will go through the rest. I think you are tired, and B2 are really very tired. So
This is like what we just did.
So this is 1, 1, and 5, 0. Negative 3 plus 3, so it's going to be 0. Negative 3 and the negative 2, so it's going to be negative 5. Negative 3 times 5, which is negative 15 and 0. Multiplying by negative 2 plus 2, so it's going to be 0. Negative 2 plus 1, so it's going to be negative 1. Negative 5 plus 1, which is going to come up to negative of a 4. It's once more, negative 3 plus 3. Negative 3 times 1 with 3. Negative 3.
Not to negative 9 because you multiplied the first row by 2 and then you minus.
Okay, negative 2, which is negative 8 plus 1, which is going to develop. This is why I had to review that. This is going to be negative 9. Okay, negative 2, 1, it's going to be negative 1. Negative 2 times 5, negative 10. Plus 1, it's going to be negative 9. For the second row, negative 3 plus 3 equals 0. Negative 3 minus 2 is negative 5. Negative 3 times 5, negative 15. And plus 0. فراس احنا مش مركزين 1 3 2 okay once more 1 negative 2 and 1 5 0 and 7 so negative 2 plus 2 equal to 0 negative 2 plus 1 negative 1 negative 10 plus 7 so it will develop negative 3 yes yes okay negative 3 dividing on negative 5 for the second row, I will have 0, then I will have 1, then it's going to be 3 and the 0. Multiplying or adding on the last row, you will have all of them zeros. Multiplying by negative 1 and the adding on the first row, negative 1 plus 1 equal to 0. Negative 3 plus 5 is going to come up to 2. And this is the final form, which once more can be rewritten as x1 plus 2x3 equals 0 and x2 plus 3x3 equal to 0, which means x1 equal negative 2x3 and x2 equal negative 3, I'm sorry, x3, am I right? So yes. The solution set will be, okay, will be negative 2x3 instead of x1, will be negative 3 of x3 instead of x2, and x3, taking x3 as a common, I will have negative 2, negative 3, and 1, and so the null space of A, it should be the span of the vector, negative 2, negative 3, and 1, okay? Which can simply multiplied by a negative 1 because this variable multiplied by any number. So it's going to be 2, 3, and negative 1, which actually it is one of the values, 2, 3, and the negative 1. Where is 2, 3? Yes, this is right. Okay. يبقى خلي بالك, please take care, but you may like to multiply a negative 1 or positive 1. This go with the context of building a vector depends on a scalar with anything. Okay, so for this problem, all you have to do is to solve for ax equal to 0. Here, he's stating that which of the following sets are linearly independent. How to check? How to check if they are linearly dependent? What's the condition? That one of them should be a connection from the other vectors. Yes?
Okay.
Okay, so let's see. I will check the first one. All I have to do in this problem, is to solve the system ax equal to 0 with each and every one of them. Remark, he is not making your life miserable, as he already gave you the first two vectors are the same. So the idea here is to be sure how to write the A matrix. Do you know how to write the A matrix? Do you remember now? I'll take the first vector and the first column. Am I right? So once more, 1, 0, and 1. بعدين 0
5
and 5 و2 بعدين for the last one
1
what are we searching for? We are searching that we reach a unit matrix. If we have a unit matrix, then these two vectors are not going to be dependent. So if I multiply by negative and adding on the last row, I will have 1, 0, and 1. 0, I will divide on 5, 1, 0. Negative 1 plus 1, which is 0. Negative times 0 plus 2, so it's going to be 2. Negative times 1 plus 3, so it's going to be negative 1, I believe 2 also.
Oh.
So the next step will be multiplying 1 by negative 2 and adding on the last row. I believe this system is independent since you can reach 0, 1, 0, 0, 0, and 2, which if you want to have it, it has a rank of 3, so these 3 vectors are independent.
Okay.
So he's searching here for the linearly dependent. So this set is independent. So no. I'm going to check for the second set.
Okay.
Okay, so all I have to do is to just replace the last row by
1 5 3
1, 5, and 3. We multiplied the second row 0, 5, and 5, so just dividing, it's going to be 5 and 5. And multiplying and adding, negative 1, 1, it's going to be 0, negative 0 and 2, it's going to be 2. Negative 1 times 1, it's going to be negative 1, plus 3, so it will be 2. Yes? Am I right?
أنا شوي مركز
Yes.
مع حضرتك دي.
Okay, then as you can see, the second row is an image from the third row. So if you try to isolate negative 2, multiplying by negative 2 and adding, all these numbers will be صح?
Okay.
So this set is the dependent set of vectors. يبقى الست اللي موجودة دي هي دي الست اللي ايه؟ اللي dependent which is